ranks for online training or whatever, now you have to like you probably have to regenerate it from scratch or something, which is a little annoying, but not the worst.
Right. Okay.
Yeah. So on the APS side, we have defaulted to doing the single machine. And then we perform sharding and fusion on the back end, like at training time, basically.
I see.
Thanks for answering, Michael.
And so these symbolic
No
loops,
problem.
like the loops over features, they're within like the outer shell of the sort of
Yeah.
full
So
embedding
you can
op.
imagine that loop. Like, what does TorchRec do? TorchRec takes this loop and turns it into a single op. Like that's, and it also handles the all to alls. Uh, and that's basically like what the kind of DMP or like distributed model parallel does in TorchRec.
But for some reason, our approach is to take this and trace into it enough to break it apart into individual calls, and then later we're going to fuse them again. Why not just trace the outer op?
Well, so this is what Ed
That's what I did
is
in the
talking
other
about, like the
thing.
two approaches.
Yeah.
Yeah.
Okay.
But to be clear,
So he
there
did
is
both
no
both
symbolic
ways
version of this
basically, and
loop.
then we can try and figure out which one we actually want to do.
Okay, that makes sense. Thanks.
Testing. Can people hear me? No. Hmm. Hello? Hello? Can people hear me?
Um, kind of. I heard that. I can't tell if you're like trying to move on or what.
I do, but if my internet's bad, then maybe someone else should share the second half. Oh man.
Do we have a topic? Maybe that person can just drive the second half.
Foz, can you hear me?
Yeah,
Can you start the second half? I'll take
sure.
notes.
Sounds good. I'm not sure what I would share on the screen. Um, I guess I can share the FSTP code, um, where we actually uh, have those hooks. So, okay. All right. So one of the most sort of important things that happens in FSTP is the stuff that happens in backwards. And the way that stuff happens in backwards is through hooks. We do a lot of um, unsharding there. We do the all reduce there, and the hooks are chained in this sort of maybe surprising way. Sorry, this is fully shard. Um, right. So register pre-forward, or is this pre-forward? Pre-backward hook. Pre-backward. Um, so register pre-backward hooks uh, does the actual registration of the hook. This is where it happens. This happens on all the intermediary output tensors of the layers as well as other things. And one of the things that happens in the pre-backward hook, so let's find it, is that you actually register, where's post-backward? So the pre-backward hook does a lot of the sharding for the memory layout stuff, and then post-backward hook is where the reduce scatter actually happens of gradient. And so we need both these hooks, or the algorithm just doesn't work. Um, you can see that here it's handling the uncharted grad and then cleaning up memory after itself. One of the where did we register it? So the registration of post backward hooks happens on the accumulated grad. And we can see it right here, right? So from the flat parameter, 10 flat parameters intermediate, that doesn't really matter. We basically have the flat parameter at this point. We get the accumulated grad, and then this is where we register the post backward hook. So what does that mean from a compiled FSTP perspective? It means when you have traced, there's like sort of two things that matter here. One is we need to, from a purely mechanical perspective, inside dynamo tracing, you can't graph break on this on the register hook call itself on the tensor. Today, that is a graph break. And if we want full graph capture, we can't break on that. So keep that in mind while I explain the rest. So imagine we handle this properly in some way. And I'll go over ways to do that in a second. Now, when a sort of sub goal that we've been treating this as, that maybe isn't the right one at the moment, is when you are done with forward, the hooks that would normally be there in eager as a non-compiled should be there going into backwards. So if I have some set of tensors, they have hooks registered, backward hooks registered on them. When I go into backwards, those same hooks should be there. Otherwise, the whole backward part of the algorithm doesn't work. And the way we have approached this so far, or at least the naive approach, was like, well, you know, forward tracing is done, backward hasn't started yet. You have collected some information about what is being registered as a hook and what is being registered on. Keep track of that. And then when you are done with forward, apply it to all the residuals, or apply it as residuals. So what does that mean? When we are finished wrapping up forward compilation in Dynamo, when we finish up the forward trace, there's basically three kinds of tensors floating around. There's the inputs, the placeholders in the graph. There's the outputs, which is what gets mapped to this output object in bytecode and remapped back to sort of the original calling convention outputs of whoever invoked the function that you're tracing. And then there's intermediaries. Intermediaries that are tensors become outputs, or they should have already been cleaned up by effects going, oh, this isn't used anymore. You like basically delete, and then they're not alive anymore, or intermediaries that are non-tensors, which don't matter for this. So, okay, so for the intermediaries that are tensors that get mapped to outputs, this is behavior that you do want, because it essentially means that there is some value left in the graph that isn't getting deleted, that still maps to an output. The approach we've taken is for every tensor we have a register hook on, we just apply that in the bytecode when we are finished tracing. So it doesn't go in the graph. And I'll talk about why it doesn't go in the graph in a second. And it doesn't go in the graph, it doesn't become an op. And you iterate over all the tensors that have a registered hook, and you just call register hook. And this actually works. AOT autograd and inductor aside, with just the eager backend, this works. The hooks get invoked, and you can trace FSTP and produce identical results between PT2 compiled FSTP and non-PT2 compiled FSTP, as measured by looking at the loss after training on all the processes involved in the training. So, okay, so this approach works at least very naively, but where it doesn't work, or where it breaks down, is the moment you want to do something more complex than just eager dynamo. It's with AOT autograd and therefore by extension inductor. It doesn't work because what happens is, if you recall that I said that intermediates that are still kept alive become outputs, this becomes a problem, because what ends up happening is you end up with values that should not have been alive, but we are keeping them alive because we have a register hook call on them, and then they get mentioned in the bytecode, and therefore they don't get thrown out. And this causes problems for two reasons. One, now your AOT autograd has a nonsensical graph in it. In a very simple example, let's see if I have this available.
Actually, Voss, why don't we take the question from NYC?
Oh, I'm sorry, I missed a hand. Please go ahead.
Just to confirm, if an in-place happens on the tensor after the hooks has been registered, I guess you smoothly write an error, because you cannot.
Say that again?
So if the user does t.register hook and then t is modified in place afterwards.
Were you asking what happens?
Yes.
With the intermediate approach, it doesn't matter because as long as
No, Voz, it does matter because
well,
after you modify the parameter in place, its grad fun is different. So in fact, this approach doesn't even work if you do a mutation like this because you have no way of accessing the original grad fun in this situation.
my answer was kind of that it doesn't matter because intermediates won't work for AOT autograd as they're written now.
Well, yeah. So also, yeah, I don't want to spend too much time explaining this because it doesn't
Yeah,
work. So
exactly.
Yeah.
let's
That's
work on the version that works.
yeah. So
As long
that's,
as it's an error, that's fine. As long as it's an error.
so the well, it's not an error. It's just it's probably will be sounding incorrect. But the most important thing is if with an intermediate hook, if you try to lower it into AOT autograd as it is, your tangents are going to be wrong, and then when their gradifan will be invoked with a non-grad, which is just like it gets nonsensical. In a very let me find the graph here.
Okay, I'm happy to not dive into that, Ed, if you prefer. That's fine.
Yeah, I want to move this along to like talking through what
Yeah.
our alternate plan should be. So,
Sure. Okay.
Voz, do you mind if I pilot a bit? I think my internet's better now too.
Yeah, that's fine. I was just setting up context for the problem.
So there are two general approaches we can take to like deal with this in a more robust way. So one is the one that Voz wrote a post about, which is essentially if you have consolidated forwards and backwards, then you just sort of like make sure you keep track of the hooks properly and then you call them again when backwards happens. But everything is happening inside Dynamo. So essentially Dynamo knows how to do backwards, knows how to insert hooks, and it can, you know, smoothly compile into them. And people didn't like this because like, you know, we don't want to force you to have to compile forwards backwards all in one go just to use FSDP. So we're gonna like make a stake. We're gonna try to give a fair shake in the last 15 minutes to the original plan, which was, can we somehow like put the hooks in AOT autograd and like have it work? Question mark. Question mark, question mark. Like, how exactly is this going to work? So there are a few things that make this challenging. So the first problem is that these hooks have arbitrary Python code in them, right? Like they are going to be consulting like data structures, and FSDP does this. They're like looking at random Python state that is changing over time, and you need to make sure that, you know, you actually install guards on them the same way Dynamo does them. So normally AOT autograd handles backwards, but clearly AOT autograd can't handle these things. You need Dynamo somehow to be involved to make sure you get safety in this case. So the second thing that is tricky is essentially when you do a register hook call inside of the forwards, right, you're going to have some function. Now, in the easy case, this will just be a global function that is available to you outside of Dynamo. But in FSDP, oftentimes these functions are like local variables, which were some global function plus a bunch of partially applied parameters that were computed locally as part of the particular run you were doing. And, you know, that together constitutes the backwards hook. So, you know, that means that the hook here isn't actually a Python object you can get your hands on, right? It's this like simulated Dynamo variable tracking thing that doesn't actually exist at the point in time you like until you actually run the code in question. So that's another problem you have to get past. So these problems are not unsolvable, probably. So like to solve the hook problem, you want some sort of compiled backwards thing, right? So the idea is that AOT autograd isn't really going to actually compile the backwards function, right? Instead, it's going to somehow produce a traceable backwards graph that has literal Python calls inside of it so that later when you're running compiled backwards actually is running Dynamo on this, you know, FX graph running the backwards, including the hooks, and then you just go ahead and actually run them in that situation. So probably this works. There's some question about what exactly AOT autograd is doing though, because like you need like a concept of an AOT autograd. Is Brian here? I hope Brian's here. Yes, Brian is here.
I'm here.
You need some concept of an AOT autograd thing where it like is unable to compile the backwards. Like you must run it under compiled backwards. I'm not exactly sure how this should work. And you have another problem, which is that if you do run the full joint graph stuff that AOT autograd normally does, and you probably do want to, because I don't know. Like, are you going to run the entire gauntlet of AOT autograd? If you do, then AOT autograd is going to try to trace to the graph, and it's going to try to run the hooks. So you need to make them not run the hooks, and instead run some sort of stubby thing that like turns into a call function to the Python object, so that later compiled backwards deals with it. Any comments, questions about like potentially what you'd have to change in AOT autograd? Go ahead.
Sorry, I mean,
But
Go ahead.
I think I missed exactly how does that help you with how do you register the hook?
Oh no, we haven't even talked about how to register the hook.
Oh, okay.
This is just like somehow you've got the hooks. The hooks are regular functions, but you still need to feed it into AOT autograd, and something needs to happen so that they stick around, so that they're in the backwards FX graph, so that compiled autograd can get at them. So like there's like this long chain of events that needs to happen before it actually works. Brian?
Oh, I was gonna say, going back to the thing Vaz said about intermediates, is that like, so today we have a backwards function, like we have a custom autograd function where what does compile backwards see when it actually runs the backward? It just sees the backward call of the custom autograd function, and it gets the grad outs. And we don't have a way of like poking at the intermediates from the forward to register anything on them, which I think is the thing you were saying earlier, right? And do we effectively need a way to do that, or can we get away with not doing that?
So Brian, are you skipping to the other problem, which is how do we like generate these functions in the first place in Dynamo?
I guess I was talking about the same thing Album was talking about, which is how do we install the hooks and what do we install them on?
Okay. So let's forget about AOT autograd for a sec. Now about what do we install the hooks on, right? So, for intermediates, we never materialize the tensor, right? So you can't put the hook on the intermediate tensor. There's no intermediate tensor, right? Like it could have been fused away inside inductor for all you know. So what you have to do instead is you need to create an AOT autograd custom function where the backwards has the call to the hook already embedded in it, so you don't actually have to register the hook.
I see.
Is it actually true? Are you guys overgeneralizing? I mean, this is only for FSDP, and FSDP will never put a hook on something other than a parameter, and we're never going to fuse parameters away, are we?
That's not
well, it
true.
puts up some things that are parameters. Yeah, sorry, go ahead, Ed.
Vaz, I think you're going to say the same thing.
Oh, yeah, it does, right? Like the outputs of the layers get hooked, and and then inside the backwards accumulator grad gets hooked also with a post backward. There's definitely stuff that isn't parameter. There's stuff that some of the stuff comes off of parameters, but the outputs of the layers are like true pure intermediaries.
Put the hooks on the activations.
Because for each layer you recursively wrap in FSDP, that layer needs to trigger an all gather in the backwards.
Right.
Yeah.
Okay.
So just to go over the mechanics of our initial approach, we actually tried a like no intermediates, outputs, inputs only residuals, which is like a lot simpler, and it like that was how I found the intermediates as bad citizens. Yeah. Yeah, so one thing that was kind of kicking around in my head is I think Brian mentioned autograd function backwards, and the way we do that is we like speculate the backwards, we install its guards, and then we put the autograd function in the graph, and then we sort of like hand wave away how backwards works. I don't really know if we can do the same thing with register hooks because of the problem that Ed mentioned, which is like the thing that you are registering on may no longer be there. And it seems to be a good amount of logic to like track what the actual like end thing that hook belongs to after you've done your backwards, right?
There's also another problem, which is you can't speculate, because to speculate, you need all the state to look like what it should look like when you ran backwards, and you haven't gotten to the end yet, so you actually don't have the right state.
Well, and furthermore, like the types going into the functools partial to get FSCP specific, those would be a non-starter for like an autograd backwards approach we do now, because we are very conservative about the types that are allowed to go into our speculation, and like these would be straight out.
So if I understand, the reason you register on the activation is because in backwards, the activation is the thing that happens right before you're like the gradient for the activation becomes ready, sort of signals you that you're about to work with the parameter, and so you need to unshard it. And so it's all about timing and like our hypothesis is we trace the bucketization and we serve it. But if we're fusing things away, we're changing timings, we're no longer able to use the same signal. Are we going to have to essentially re-optimize where we do the fetches?
Well,
and
to
then
be
does
clear,
that undermine?
if we like manage to put the hooks in the right spots in the AOT autograd backwards custom function graph, then you will have calls at the right times.
Yes. I think an unstated problem here, or that is also that if with how AAT autograd works today, I believe all your hooks will run after the graph.
No. So they're not actual hooks. These are like, code embedded inside of the
Hook simulations, what do we call those?
I mean, you inline the hooks into the backwards.
Yeah.
Because you don't need a concept of hook anymore.
Yeah. Yeah, right. From the perspective of the backward graph, it's just more code in the graph.
So Brian, do you think you understand like concretely what we propose to change in AOT autograd for this? Because if the answer is no, then that's a bad sign.
I don't think I understand concretely what you would change in AOT autograd to do the thing that you want to do. Tell me if, for example, if we're saying like inline the hooks directly into the backward graph, could that look something like if I have an activation in the forward and then I install a pre-hook in it, then in the backward graph I have a node corresponding to the activation, and then what I really want is like another node right after that node in the backwards that corresponds to random Python hook function we're going to call.
Yes, before, but yes.
Before, yeah. Can we easily do that in AOT autograd?
So like maybe one way to do this is like, okay, so you're sending, oh my god, this is so bad. Okay, so like let's see. So AOT autograd operates by getting a forward function. Actually, Albin, go ahead.
Just to confirm, if you do not want to just inline the hook, you want to have a Python function there, are you okay with inlining the hook into whatever
Python function because it manipulates Python state, and like we cannot do this correctly until compiled backwards runs. Richard?
Sorry, so let's say you do have this thing where you just shove some Python code inline into AOT autograd backwards. Who actually ends up running it? Like Inductor or someone else?
So you would also need a thing that forces you to run compiled backwards for this. But then what would happen is that compiled backwards would then actually run it, producing
Okay,
the
so
final graph that you compile.
So it would run what is inside the hook, but you would not be able to optimize what is inside the
No,
hook.
you can optimize what's inside the hook because compiled backwards can compile the entirety of the backwards.
Okay, so compile backwards will actually see what's inside the hook.
Yes.
Okay.
Alvin?
Which is its own class of problems we actually haven't covered, because what's inside that hook is not very compile friendly either, but that can is being kicked.
Alvin?
Is something that would you be happy with something like registering a hook basically triggers the creation of a custom op that gets into your A10 graph as a pure custom op?
It's not a custom op. It accesses Python global state.
No, we make it a custom op, and that basically nothing will know how to run, everything will fall back, but compile backward can be smarter and detect that custom op and inline it.
I
Like,
don't know how to evaluate this solution because you're breaking the custom op invariant, which is custom ops like aren't supposed to like touch Python global state.
Are they not?
No. Richard will be mad if you do it. Brian?
Yeah, I was going to confirm something you said earlier, which is originally Vaz posted about the consolidated forward backwards idea, which used compiled autograd, and people weren't happy because that requires you to always turn on consolidated forward backwards. How is always turning on consolidated forward backwards different from always turning on compiled autograd? Because doesn't the solution we're talking about now require compiled autograd being on by default?
Yeah, so the difference is that for consolidated forward backwards, you need to have no graph breaks. You need to be able to get all the way from the beginning of SDP to your backward call. All in one.
So consolidated forward backward is no graph breaks and forward
no
also.
Graph breaks. Whereas compiled backwards allows for graph breaks and forward. Like it actually explicitly supports this. Alvin?
And
oh, go ahead, Brian.
I was responding to Albin's thing earlier, like, is it possible to do that and just not have it be a custom op and just be an arbitrary Python function? That seems like the thing we want, but
the graph that AOT autograd generates needs to be a pure A10 graph.
but
that's why. Yeah.
I thought the argument is that it doesn't need to be a pure A10 graph because the backward will get re-dynamoed when compiled autograd runs.
Well, but if there's no compiled autograd,
you're regular if you backward and there's no compiled autograd, in my opinion.
So hooks plus compiled autograd off equals error. Like you need compiled autograd to run with
hooks. I
don't
think that's too hard to do either. Okay, we are out of time. I'm adjusting down the probability that we should actually do this as opposed to consolidated forward backwards. But we can still like argue about it some more and see if we can simplify the plan. But I don't know. This just seems very complicated. And we haven't even done all the problems. Like, for example, these hooks, they're going to be closures, and we can't id match on them in the guards because they're always going to change every time we rebind new things to them. So I need to see into the closure to like see what the free variable bindings are and guard on those instead.
So you can hack by lifting all the contents of the functools partial into a global and then make it like a one-time thing, and then now you have a bunch of global guards. I did do that, but it's so gross, and I can see problems with it if you have mutations on that state, because you have to do like the side effects tracking on the global now.
Okay. So there's going to be some more discussion at the PyTorch Hangout right after. So thanks, everyone. See y'all.